So I will just quickly revise it. Oblique projectile, its equation of trajectory or equation of path followed by the projectile is y equal to tan theta x minus g by 2 u square cos square theta into x square. This equation gives you value of y for some value of x. Horizontal displacement and vertical displacement are related by this equation. And from this we get the path of the projectile to be a parabola. And time of flight, it is the total time for which the projectile is in air, and it is 2u sin theta by g. So if total time of flight is 2u sin theta by g, time of ascent will be half of it, which is u sin theta by g, and time of descent will also be u sin theta by g. Okay, time of flight. Next is we have relations for maximum height and horizontal range. Maximum height and horizontal range. So let us see, first of all, what is maximum height? Maximum height reached by the projectile. This is denoted by capital H. Maximum height. What is this? Suppose I am throwing a body from the origin with some initial velocity u, which is making angle theta with the horizontal. Initial velocity u making angle theta with horizontal. Then its path will be like this. Okay. Now during its journey, its vertical displacement. What is happening to vertical displacement? The displacement along y direction. It is going on increasing. Increasing. At one point, it becomes maximum. Where at this point, this is the maximum vertical displacement. After this, it is decreasing, becoming zero. So, maximum height is the maximum vertical displacement of the projectile. It is the maximum vertical displacement of the projectile. Vertical displacement. Okay. So how to find out this vertical displacement? First point is that we should understand. You are throwing it with velocity u, making angle theta. Then this will be horizontal velocity. This will be vertical velocity. U cos theta, u sin theta. Yesterday we discussed in detail what happens to each component. U cos theta does not change with time. It remains constant. U sin theta changes with time. First decreases, becomes zero, then increases in the opposite direction. Now the point is, maximum height is decided by which component of velocity? Is it u cos theta or u sin theta? Who will decide maximum height reached? Horizontal velocity or vertical velocity? It is a point of common sense. Which velocity will decide how high the projectile will go? Horizontal velocity or vertical velocity? Vertical velocity will decide.
So u sin theta will decide, sir.
Maximum height depends on vertical velocity. Vertical velocity, greater the value of u sin theta, greater the height it will reach. Okay. Now I'll apply h equal to ut plus half gt square. H equal to ut plus half gt square in vertical direction. What is h? H is maximum height. We want maximum height. So in place of h, I should write maximum height, capital H, equal to u. Which u? Horizontal or vertical? Vertical. So u sin theta into t, time. How much time? How much time does the projectile take to reach maximum height? Is it the time of ascent? Time of ascent. Or in other words, you can write uh, half of time of flight also. You can write like this also. It will reach the maximum height in half of time of flight. Okay. Minus, because it is going up, g is downward. Minus half g t square, again capital T square. Okay. Right. So h is equal to u sin theta into t by 2. T by 2. What is t? We already got yesterday time of flight. Time of flight is 2u sin theta by g. So putting that t here, 2u sin theta by 2g minus half g t square. T square is 4u square sin square theta by g square. Cancellations. 2 cancelled. G 1g cancelled. 2 cancelled. Then what is h? This is u into u square sin theta sin square theta by g minus u square minus 2 u square sin square theta by g minus 2u square sin square theta by g. 1 minute. See here, this is not t, right? This is t by 2. Here also we should put t by 2. So I will change this. First term is okay. In the second term, this is not t square, this is t by 2 square. Okay, so what do you get here? Half into g into t by 2 square. That means u square 4u square sin square theta by 4g square. Now cancellations, g 1g 2, no, this 2 will be as it is. 4 cancelled. 4 cancelled. And you have here minus 1 by 2 u square sin square theta by g. What will be it? U square sin square theta by g minus u square sin square theta by 2g. So it will be u square sin square theta by 2g. This is the formula for maximum height of the projectile. U square sin square theta by 2g. Depends on initial velocity u and angle of projection theta. Or in other words, on vertical velocity. Okay, maximum height. Next one, time of flight, maximum height. Then another parameter is horizontal range of the projectile. Horizontal range of the projectile. What is this? Simple. Again, consider a projectile. You are throwing an object from the origin with initial velocity u, making angle theta. Its path will be this. Okay, now horizontal range. Range means distance covered. In which direction? Horizontal direction. This distance, the maximum horizontal displacement of the projectile is range. It is the maximum horizontal displacement of the projectile. Range. Okay. Now, how much will be this range? How to find its value? Again, we should think from the point which velocity will decide range. Which velocity will decide range? Again, two components of velocity, u cos theta, u sin theta. Horizontal range will be decided by u sin theta or u cos theta. Which velocity will decide the horizontal range?
U cos theta.
Horizontal velocity will decide how far the projectile goes. Vertical velocity will decide how high the projectile goes. So, horizontal or range depends on horizontal velocity. Horizontal velocity, right? Then, which formula should I use here to find horizontal displacement? Range is after all displacement.
Sir, h equals to ut plus half gt square, but h displacement equals to sir.
Here the point is we are talking about horizontal direction. So if you remember, the motion of a projectile in horizontal direction is uniform motion. Uniform motion, velocity remains constant in horizontal direction. So if motion is uniform, we need not use the kinematic equations. We will use displacement equal to velocity into time. Displacement equal to velocity into time. Okay. Which displacement? Horizontal displacement. How much? Maximum. That is what we are calling range. So R is equal to velocity. Which velocity? Horizontal velocity. How much is it? U cos theta. Into time. Which time? Is it the time of ascent or time of descent or total time of flight? It is the total time of flight. Total time of flight. And we know time of flight is 2u sin theta by g. 2u sin theta by g. So range R is u square 2 sin theta cos theta by g. 2 sin theta cos theta by g. And from your mathematics trigonometry, you might have got this relation. 2 sin theta cos theta is sine 2 theta. Trigonometric identity. 2 sin theta cos theta, not identity,
Yes, sir.
a relation. So
Yes,
you
sir.
get u square sine 2 theta by g. So finally, range of the projectile is u square sine 2 theta by g. Range of the projectile. How far does the projectile go? U square sine 2 theta by g. How high does the projectile go? U square sine square theta by 2g. Formulas are slightly different. You should not get confused. U square sine square theta by 2g, u square sine 2 theta by g. Okay. And a important point regarding this range is, see, for a given velocity, that means u is fixed. U is fixed. Then what does range depend upon? If u is fixed, u is constant, g is however constant, then range changes with theta. If you change theta, angle of projection, range changes. For what value of theta will the range be maximum? For what value of theta will the range be maximum? The range is maximum for theta equal to, okay, or I will write like this. For a given velocity, range is maximum if sine 2 theta is maximum. Okay, directly proportional. Sine 2 theta, if it is maximum, range will be
R
maximum.
is directly proportional to sine 2 theta.
And what is the maximum value of sine 2 theta? The maximum value of sine 2 theta is 1. Sine cannot take a value greater than 1. Its range lies between minus 1 and
90
plus 1.
degrees.
And sine 2 theta is 1 means 2 theta is equal to 90 degree. That means theta is equal to 45 degree. So for a given initial velocity, if you project a body at 45-degree angle with horizontal, its range will be maximum. Its range will be maximum. Therefore, R is max for theta equal to 45 degrees. Important point. And we use this without our knowledge. Suppose you are playing cricket, you are fielding at the boundary. You get the ball and you need to throw it back to the wicket keeper. Okay. How do you throw it? Will you throw it? This is the ground. You are here near the boundary, and the wicket keeper is here. To throw the ball to the wicket keeper, will you throw it like this, or will you throw it like this,
So the
or will you
second,
throw it somewhere between?
so between, sir.
Somewhere between. In order to cover the maximum distance, range to be maximum, you throw it at a angle which is neither too large nor too small, and that is 45 degree. If your angle of projection is 45 degree, your range will be maximum.
Sir,
Yes.
so can we say that vertical displacement should not be too long or too small?
Range is not decided by vertical displacement. Whatever it is, range is only decided by horizontal displacement, which is horizontal velocity.
Okay, sir.
And if you take this, you might have heard recently, 4 or 5 months ago, we got gold medal in Olympics. In which event? Javelin throw, right? Neeraj Chopra.
Yes, sir.
We got a gold medal. And the distance up to which he threw the javelin, I think it was some 82 meter, I think. 82, 84 something. Let us say 82. For which he got gold. And the second prize, second silver medal, it went to some 80.5 or 80.4 meter. So there was a slight difference of 1.5 or 2 meters, that's all. Okay. What do you think makes this difference? Throwing a javelin is just like a projectile. Throwing a javelin is just like projectile. If you want your javelin to cover maximum distance, that means its range should be maximum. What are the two things which decide this range? One is u, the other is theta. Okay. And every player, every athlete who goes up to the level of Olympics, he will be having the almost the same level of arm strength. same level of stamina, right? So you will almost be same for both gold medal, silver medal, and even bronze medal, because they will be they would have got training up to the same level, so that you will be same. But the point here is whoever throws the javelin at an angle closest to 45-degree, he can throw it further. So sports is not only about stamina, strength, muscles, all these things. It is also about technique. This is the example. Even if you throw even if you throw it with u greater than this Neeraj Chopra, but if you don't maintain this angle 45-degree, you cannot reach the maximum range. Right. That is the point. (45°). These are the 4 parameters of a projectile. What are they? First one is equation of trajectory. Y is equal to tan theta x minus g by 2u square cos square theta into x square. Second is time of flight, 2u sin theta by g. Third is maximum height, u square sin square theta by 2g. Fourth is horizontal range, u square sin 2 theta by g. 4 very important parameters of a projectile. Question for you. A cricketer throws a ball with velocity 20 meter per second at 30° with horizontal. Find number 1. Time of flight of the ball. Number 2. Maximum height reached by the ball. Maximum horizontal distance covered by the ball. And number 4, height of ball when it covers 10 meter along horizontal.
Sir,
Yes.
should you take GS10?
Yes.
Okay, sir.
You have 3 minutes to do this. Start. Is everyone solving or not?
Doing the last one, sir.
Yes. Answers are how to solve this.
Sir, first one is 2 seconds. Second one is 5 meters.
Sir, one's gonna go up.
So the ball is thrown with 20 meter per second at 30-degree angle. So you have u 20 meter per second, theta 30-degree. What is the first thing? Time of flight. Time of flight of the ball. 2u sine theta by g. 2 into 20 into
2.
sine 30 divided by 10. So 2 into 20 into 1 by 2 divided by 10. 10 ones, 10 twos. 2
Sir,
second is the time of flight. Next,
sir, 5 meters.
maximum height reached. Maximum height reached. H is equal to u square sine square theta by 2g. U square 20 into 20. Sine square theta, sine square 30. 1 by 2 square, 1 by 4 divided by 2 into 10. So 10 ones, 10 twos, 2 gone, 20 by 4, 5 meter. Maximum height is 5 meter. Okay. Third, horizontal range. U square sine 2 theta by g. 20 into 20 into theta is 30, so 2 theta is 60. Sine 60 by 10. 10 ones, 10 twos. So 40 into sine 60 is root 3 by 2. 2 ones, 2 20s.
It's made
20
like
root 3
34
meter.
meters.
You can put 1.732 in place of root 3, you will get that value. Fourth one is height of the ball when it covers 10 meter along horizontal. So if the ball is going like this, it will fall somewhere here at a distance of 20 root 3 meter from here to here. But when it has covered a distance of 10 meter along horizontal, that means let us say somewhere here. It is not half of the distance, somewhere here. It has covered 10 meter distance. Then its height is this. This is y, this is x. So y equal to tan theta x minus g by 2 u square cos square theta into x square. We want y height. Tan theta. Theta is 30 degree. into x. X is horizontal displacement 10 minus g is 10 by 2 into u square 20 into 20 cos square theta. Cos that is root 3 by 2. So square is 3 by 4 into x square 10 into 10. Tan 30. Tan 30 is 1 by 2 by root 3 by 2. 1 by root 3 into 10 minus so I can write this 10 into 10 into 10 here, 10 into 10 into 10 g into x square. Okay, so 10 ones, 10 twos, 10 ones, 10 twos, 2 ones, 2 fives. This will be 5 by 3 by 16. So 5 into 16 by 3, which is 10 by root 3 minus 16 5 80 by 3. You can calculate that, you will get the value here. Okay. This is the information about oblique projectile. Oblique projectile means if the point of projection and point of striking lie in the same plane, then it is an oblique projectile. Second type of projectile is horizontal projectile. Horizontal projectile. What is this? Suppose you are standing on top of a tower or building. Height of the building is h, and from top of this building you are throwing a ball or something in horizontal direction with initial velocity u. Horizontally, you are throwing it exactly horizontally with velocity u. Then what happens? What will be the path of this body? What path does it take? Because of the horizontal velocity that you give at the time of projection, it tries to travel in straight line like this. But the moment it leaves your hand, gravity acts on it and gravity pulls it down. Due to the horizontal velocity given by you, it is trying to travel along horizontal direction. So due to the pull of gravity, it has to go down. So it has to travel in both directions simultaneously. Its path will be this. Its path will be this. So if we observe how we are getting at the time of projection, it is only u, horizontal velocity. After some time when the body is here, u will be as it is because horizontal velocity is not affected by acceleration due to gravity. But because of acceleration due to gravity, here it will gain some vertical velocity also. Vertical velocity also. After some more time, this u remains same. Vertical velocity increases. After some more time, u remains same. Vertical velocity further increases. When it strikes the ground, u remains same. Vertical velocity will be maximum. Because of this, it takes the resultant path like this, like this, like this. And this is also a parabolic path. This is also a parabolic path. Now, what parameters do we get to study this horizontal projectile? First is time of flight. Time of flight. Time of flight is decided by which velocity? Horizontal or vertical?
Vertical, sir.
Vertical velocity. What is the vertical velocity that you are giving to it at the time of projection? 0. Vertical velocity at the time of projection is 0. You are giving velocity only along horizontal direction. but because of acceleration due to gravity, with time, it is gaining vertical velocity. Okay.
In the
So,
form of gravity, sir.
to get time of flight, I will apply h equal to ut plus half gt square. H is equal to ut plus half g t square. Which direction? Along vertical direction. Along vertical direction. So, along vertical direction. What is h? H is h, height of the building. U, which u? Vertical velocity, which is uy into t, plus or minus, plus, because it is coming down, half g t square. Okay. Now, uy is 0. Initial vertical velocity is 0, plus half g t square. That means t square is equal to 2h by g, or t is equal to root of 2h by g. Root of 2h by g is the time of flight. Second one, horizontal range, or simply range. Which velocity decides horizontal range? Horizontal velocity decides horizontal range. How is the velocity along horizontal direction? Constant. So, displacement is again same, velocity into time. Displacement is velocity into time. How much is displacement? Range. This is the horizontal displacement. Okay. Velocity. Which velocity? Horizontal velocity. How much u? You are giving u horizontal velocity into time. Which time? This time. So, r is equal to u root of 2h by g. These are the formulas for time of flight and horizontal range for a horizontal projectile. There is no need for formula for maximum height, because the height of the tower or height of the building from where you are throwing, that itself is the maximum. You get these two things here, time of flight and range for a horizontal projectile. Okay, so tomorrow we will do some basic models of questions based on projectile. Then we will see the next topic. That will continue tomorrow.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir.